So first and foremost, of course, thanks to ISNT for inviting me to talk about this. At the same time, I'd also mention that a good part of what I'm going to share has already been just shared in the previous session, 3C, where again Johannes spoke, and we had totally four invited speakers, all excellent speakers in this domain, who have covered a lot of ground on this topic. So I'm going to be a little fast and it's more like a recap, I should say. There could be some elements which are new and of interest to you, so hopefully you'll find that interesting. Okay, so I'm going to talk about digital transformation, and again it goes back to NDE 4.0 and specific to industrial inspection. I should, when you give an invited talk, and Johannes just read out my brief bio. Obviously, it's an assimilation rather of experience and knowledge over several decades, and all that doesn't happen if you do not have the right foundations at the school level, college level, and then of course places where you work. So thanks to all of them for what I am today, and of course in a topic like this, which is very new, you resort to a lot of web resources and other people's publications and all that, and borrow them so that you can express the content much better. So you will see many of those. Again, nothing surprising to this audience that the industry spectrum is extremely vast. That's where both the diversity and the challenges come. You're dealing with different materials, complex shapes, sizes, hazardous environments, damage mechanisms, everything. Just look at these pictures and you can, in your mind, think about how different they are. An aerospace to an oil and gas to an automotive to a power to a transportation to a shipbuilding. And that, while it is exciting for an NDE engineer or inspection engineer, also brings along challenges with it. And the biggest challenge is about quality. So, we as inspection or NDE engineers have the responsibility of ensuring quality in all the products, in the components, in the structures which they are built, both at the manufacturing and of course beyond that once they are put in service. And of course, engineering failures do happen. These are not pretty pictures which we would like to see in our lifetime, but they happen. You cannot avoid them, be it a wind turbine, be it a locomotive or a train, or including something as sophisticated as a space shuttle, or something as mundane as an amusement ride. All of them do have a potential to fail because of various reasons. It's just not one reason. It could be material defects, it could be manufacturing defects, it could be the way it was operated, not within the zone of operation parameters and going beyond that, things like that, high temperature, high pressure, whatever it is. So failures do happen, and it's our job and our responsibility to see how we can avoid them. And NDE, as you know, is a cradle to grave technology, starts with raw materials and goes up to the end of life. So clearly we have a very big role to play in ensuring that engineering failures do not occur. And the one way we can always do it is to combine NDE with a lot of the other adjacent technologies, adjacent concepts, and then combine them, synergize with them, and then grow to the future. So clearly, the future is all about what is called as continuous next, where our organizations will constantly innovate, integrate, and then deliver. So creating the future is by the amalgamation of several technologies which are happening around us. And Industry 4.0 and NDE 4.0 is nothing different. It is just a framework, a very specific framework, where we are trying to bring all those things together to see how we can make life better for all of us on planet Earth. And clearly, again, you've heard this many times, so I'm not going to repeat it, but yes, NDE 4.0 is gaining a lot of importance. Again, Johannes, the chairman of this session, is driving a lot of activities, including the IC&DT, as you mentioned. And of course, the fact that, people like ASNT have brought out special issues. This was the last year's special issue on NDE 4.0. And those of you who attended Johannes' talk in the previous session can see that how many special issues on different journals, as well as now the books, including the handbook, and of course the world of NDE 4.0, which got released recently. So you can see the momentum being built up on NDE 4.0 in general across the globe, and we can't be left behind. So here in India, I know we have been talking about it since the last 2 years, but we are hoping to see some momentum gain, in this topic. So clearly, in the industrial revolution, if you see the change in NDT emphasis is there for everyone to see, and obviously we are in the current as we talk about Industry 4.0, NDE 4.0, lots of assisted and autonomous decision making, right? That's what it's all about. A lot of autonomy, a lot of automation, a lot of automated or semi-automated or assisted decision making. That's where the job nature of the job is also changing with every single industrial revolution, and one has to adapt to the changing revolution. Just like we have done so in our personal lives, we have accepted the whole concept of digital transformation. Again, what was highlighted by Johannes in his talk in the previous session. So again, nothing new. Again, this is a repeat of what has been shown, but clearly just for the benefit of those who were not there in the previous session, re-emphasizing the fact that there are three different aspects of digitalization, and digital transformation. And usually you will start with the first step, then go on to step 5, which is like transforming the entire institution. And it's like, again, Johannes mentioned in his talk, it's a process, it's a journey. It cannot happen overnight. There has to be conscious thinking by the industry and the management of where to start, which aspect to take, and so on. So it's a long journey, but a journey worth taking, in my opinion. So the whole topic of digital NDT, again, this is a nice phrase which I found, I borrowed it, 21st century digital NDT will accelerate affordable fourth industrial revolution in a risk-averse society. So you can see in one statement, everything is there. Digital NDT is all about analysis of big data, digital twin, and so on. You have to also always maintain risks at affordable level, right? You cannot go drastically on one side and increase the risk. And we, of course, live in a risk-averse society, but we will have to manage that. And of course, it does many more things. This is again just the same thing, but again, the simplest thing you could all think of in the ND world is the fact that how we move from film to CR and DR as one of the examples of digitization. And we'll be talking more about that, so I don't want to. So the drivers for automation in ND are many, and you could pick any industry, and you'll see that at least you will pick a few of them as something relevant. It could be all about speed, quality, productivity. Sometimes it's about size and shape and volume, and of course a lot to do with operators and how they do stuff. And of course, as long as human beings are part of the process, errors can happen, and sometimes that could be the cause of many of the failures. So we could reduce that by reducing our over dependence on human operators by making them more efficient. It's not about removing them from the process, but making them more efficient by giving them suitable tools to assist them. So in a typical industrial inspection scenario, you always have a component, structure, or asset to be inspected, and depending on the damage mechanism or what you're looking at, you'll choose the appropriate ND technique. And then there is an inspection process and procedure to be adopted. You will then inspect and acquire data. Then you will analyze and interpret the data. Then you'll make some decisions and dispositions based on that. And of course, you have to maintain records and archive so that you can do some trending analysis and many other things. So the ones in blue are clearly the ones where digitization and is going to play a big role, and all of those steps can benefit a lot by using that. So there are many enablers for the whole process of digital transformation. We'll be just talking a few of them in the interest of time, and there's also the fact that we have heard many other speakers talk about it, and there'll be many more speakers coming after me who are going to talk about many things. So obviously, one of the biggest things which we heard in the last session also is the whole big impact AI, machine learning, deep learning is making, especially in terms of analysis of data and so on. Yes, a lot of background noise. So yeah, okay, I think it's gone now. Sorry. Okay, so again, you've heard a lot about it. So again, not getting into too much of details, but the fact remains that this is a big enabler for many things, and we'll see just a few examples. And there are lots of differences between the terminologies of AI, ML, and DL. But again, this is not the forum where we would like to go into that. It's more about understanding where it all gets used. So here is an example of how one of the very simplest and basic methods of fluorescent penetrant inspection has undergone transformation, like, a huge transformation. You always thought it was a very simple method, always manual, but today there are systems available which is completely automated. Here is one example which was done at GE, how the end-to-end system for automated defect detection, using an unsupervised method. It identified that, and using deep learning-based defect detection and classification, it was able to do extremely complex crack localization and report generation in something as complex as things like turbine blades and things like that. So this was possible due to the use of AI again. And when you combine that with all the other things which are happening in the world of automation and hardware, here is a completely fully automated system where virtually a human being is eliminated, except for being there on supervision, where it starts and does the entire FPI process on a given component, completely automated, right down to analysis and disposition. So something as simple as elementary method like FPI can today be fully automated, and you can make use of all these advanced technologies there. Okay, and here is again an example of how the concept of AI and machine learning has been used, primarily again focused on sensor data analysis. So that's our biggest issue, one of them. Given the complexity of methods like phased array which are coming in, or TOFD and other things, it's important to assist the operator in as many ways as possible, so they become more efficient. So here is how AI and neural networks have been efficiently used to do automatic classification of defect type and all that from basically phased array signals and so on. And of course, ADR, which is either assisted or automated, is something again you've heard in many of the previous talks. Very becoming more and more popular, and clearly we are seeing increasing use of ADR either in assisted form or automated form. Predominantly, it's still assisted till we reach a maturity level where we can call it automated. But yes, it's playing a big role, be it X-ray images, be it eddy current, be it ultrasonic, whichever, and you saw FPI. So again, moving from AI and ML to another big platform or another big enabler for NDE 4.0 and digital transformation is all about the topic of augmented, virtual, and mixed reality or extended realities. And I'm not going to spend too much time because another colleague of mine is going to be presenting this more detail at the end of this session, the last paper of this session. But the whole topic of augmented, virtual, and mixed realities is again becoming very important for NDE, because the benefits you can get are huge. Be it in terms of training, be it in terms of getting to visualize the very complex things like aircraft engines or gas turbines or anything in a plant like a refinery or a power plant, and how the whole tools of AR and VR can be very effectively used for helping the operator to make his life easy in terms of both doing the inspection as well as analyzing the inspection and then finally doing the disposition. So I'm not spending too much time because it will be talked about later by another colleague of mine. Of course, the other big enabler for digital transformation is all the use of different delivery mechanisms. A lot of digitization can be enabled if you use automated delivery mechanisms. So clearly, robotic-based inspection is something which is gaining a lot of importance. Again, can't get into the details. Anybody who wants can connect with me and we can talk about it. But excellent robotic devices to do confined space inspection, going to pressure vessels, go on pipelines, elevated places, do location where you can do the mapping, avoid obstacles, everything which you can think of, can be done with these today's robots. which are excellent. They can have ultrasonic sensor, eddy current sensors, high definition cameras. You can enable any sensor, including infrared or whatever. A different delivery mechanism is all about drones. And that again is catching the interest of the entire NDE community and inspection community, just because of the tremendous advantage. Just like robots give you an advantage where it can crawl over large surfaces, gather data, go into confined spaces where human being need not enter. Exactly the same. A drone is something which you can fly, to tall structures, large surface area, and make use of the benefits it can provide in acquiring inspection data at a very fast pace. Reduce time of downtime. Can even avoid disruptions to normal operations. You can lower the exposure to hazardous environments, increase safety of the operators, and you can get very accurate and reusable data. And of course, the simple fact that you are reducing time of inspection automatically increases productivity and things like that. So asset inspection, asset reliability, a great user of drones, and virtually every industry from oil and gas to power to renewables to offshore rigs to railways to aerospace, everybody has started to use in some form or the other. It's still in, I would say, a little early stages, but we are seeing increasing use every single day. Here is an example of how railway asset inspections are being done with drone. You can have lidars, and you can have other cameras which you can do gauge measurement between the rails, which is very important to make sure for safety of the rails and stuff like that. So here you can see a drone flying, acquiring data, getting processed, and really the track gauge measurement is getting done. And this is just one simple. And then when you're talking about tunnels, you want to inspect the rails inside the tunnel, a drone is a better place to send delivery mechanism to send. Wind turbine, one of the very popular examples for drone inspection. As you can see, very tough environments when you're inspecting a wind turbine, be it the tower or the blade. You have rope access inspections, and think about it when you're doing offshore. Extremely difficult. We are putting our operators to risk, and of course, it's going to be time consuming at all. So why not again adopt drones? So here are a bunch of sensors, NDT sensors, are starting from a simple RGB camera to thermography to ultrasound and to multispectral cameras. Some like xerography and radiography obviously cannot be used because of its other challenges, but you can see that some of the very popular techniques can easily be used. And when you do use inspections, here is a sample picture of how three-blade inspection, which would have normally taken maybe as long as 2 days or 3 days if we did it with rope access, could be done in 40 minutes per turbine. So huge productivity gain. You need not subject to shutdowns and loss of power and so on and so forth. And there are plenty of automation devices which have come. You can actually entirely do mapping with that. The other big example is the power plant boilers. Again, a huge asset, many stories tall, and a number of tubes are there. And typically they put up scaffolding, and then you send inspectors like the one you see here going and doing lots of inspection, including duty wall thickness measurements and so on. And that could today be done using a drone. Excellent drones have been designed for safety, and you could at least do a good first screening of the entire boiler from inside, and then set up scaffoldings only in those areas where you want to do greater specific measurements like ultrasonic wall thickness or anything else, rather than trying to set up scaffolding because you don't know where the damage is. So excellent screening mechanism with high resolution RGB cameras or IR cameras and stuff like that. And then combining AI and robotics, today you can actually do, robot can be doing its own path planning using AI and do most effective inspection even in complex surfaces. And again, combining AI with drones, you can entirely automate the process of drone inspection, especially for things like wind turbines. And as you can see here, completely automated analysis right from path planning of the drone to acquiring images, applying AI on damage detection, and giving you out the final output. And it helps you in doing automated damage classification, like what you're seeing here, leading edge erosion, lightning receptors, and many other features which are seen on a very large structure like a turbine blade. Of course, it's a combination of things like drones and robots, which can do a complete inspection of an aircraft. Airbus is working on this. They're combining, for example, parts which are on the higher end. How to you can have a trawler which can go there. You can fly a drone and acquire images and combine that with real-time augmented reality to really get a full visual view of data acquired with several different sensors and making decisions on any damage, or even at the quality control stage, whether everything is done before it's dispatched to the customer. So all this is also going to play a very big role in what we call maintenance strategies. And we are moving from reactive to prescriptive maintenance. And without digital transformation, that is going to be very, very difficult. Again, last but not the least, digital twins, also touched upon in some of the previous talks, cannot be done unless we talk about digital transformation and digitization. And digital twins are going to be the future, where, especially when we are talking about predictive maintenance and many other aspects. So it gives you very unique insights, which till today was not possible. So certainly we are going to see a big play of digital twins, where again we combine domain knowledge plus artificial intelligence and consistently help grow, our knowledge base in that area. So at the end of the day, everything is about driving outcomes. So you can use a combination of robotics, inspection devices, digital twins to get the kind of outcomes you want, like safety, availability, and reliability, of course. The biggest challenge we will all see is about adoption, technology adoption. And this is a very standard curve which you see, and there is always a peak of inflated expectation of disillusionment, and then there is a slope of enlightenment. We will have to go through this path, like it or not, but it's all up to us in the industry how we can change the timeline. The y-axis of this can always be changed if we do things on the y-axis at a much faster pace. So the COVID has been a big leveler for everybody, especially in adoption of technologies. The COVID has forced people and industries to use more technologies, and the world has really adopted in using things like digital twins, drone-based inspections, AI, remote inspection, everything you can talk of, even in the NDE world. So many news reports about how exponential increase in the use of things like remote inspection has happened. And of course, regulatory bodies have also helped us by, things like FAA came in and did give a guideline on remote inspection for the airlines. And that again is very, very important. And this is probably where the future of ND inspection will lie, where everything which we talked about comes together and, making the life of the operator very much simpler than where it is today, using all those technologies we talked about, and giving you top class asset integrity decisions. So there are lots of trends, and all of them are with hope. The analytics, twins, drones, remote inspections, AI, etc. So the digital transformation paradigm in ND is going to be changing every day here as we speak, and it has its benefits, be it in revenues, increased customer satisfaction, enhanced safety, accurate reporting, and faster billing cycle times, and so on. So in summary, the technology trends are changing at a pace never seen before, especially automation and digital transformation. In most cases, it starts as a hype, but soon converts to hope in many, depending on proper understanding and assessment. There is a need for faster accelerated testing of these trends with concepts of minimum viable products and pivoting, and of course, industry push needed for our adoption and deployment. So the only way for all of us in this community is to innovate, evaluate, adopt, implement, and move forward with hope. With that, thank you for your attention. Hopefully, you found some aspects of this very interesting. I know in the interest of time, there may not be time for questions, but anybody who wants to talk more about it, please feel free to get connected on any of the email given. With that, thank you.